This is a quick look at diffraction. Diffraction is another quality associated with all waves, whether they be mechanical waves or light. This particular screencast also corresponds to a simple demonstration that I've put in today's folder. That demonstration of diffraction has to do with me standing outside the door of the classroom with the lights off. You can see very well-defined shadows associated with the light. However, even though I'm not in view, you could easily hear me as I talk while outside the door. Okay, the reason for that, all of that is as follows. Okay, what I'm going to do first is set up this barrier right here in yellow, as you can see, and then right here is an opening. Let's say that this here is the doorway, and this is the wall of the classroom. Okay, let's say that I first of all simulate what happens here by using light. Light has an extremely small wavelength compared to the obstacle itself. The obstacle, the opening here of the door and the wall itself, is huge compared to that wavelength. This then ultimately means that the waves themselves are not easily able to diffract around this corner right here. When the wavelength of the light is very small compared to the objects that it's curving around or diffracting around, then you end up with these very well-defined shadows. So let me go ahead and set this into motion like so. Here's some incoming waves of light. And then if I pause it, notice that the waves are not able to easily bend around this corner or diffract around this corner, and so then therefore this portion of the classroom here is in darkness. You have this well-defined shadow being cast here by the doorway's opening. Right here is the wall. Okay, now I'm going to change this. What I'm going to do is clear these guys here. I'm going to go ahead and then simulate sound and then lower the frequency like so, so the wavelength is large. So the wavelength of sound waves now becomes comparable to the size of ordinary objects, like this opening here of the doorway of the classroom and the wall. And when you have waves of a large wavelength diffract around an obstacle or a corner of some manner, they're able to easily do so. So you do not, in other words, end up with a well-defined shadow. And even if I'm standing outside of the room, you could easily hear me, for example, if you were over here. Watch what happens when I set the waves into motion. Okay, notice how big the waves are? And then notice that they're able to easily diffract around the corner, such that if you were, say, standing over here and I was out here somewhere, you'd be able to hear me. Incidentally, in this particular applet, I'm not able to extend the yellow barrier here all the way to the right-hand side. So there is a small opening here. I'm ignoring all of that with these waves right here.